Welcome back. In the previous video, I created this demo smart contract over here, and this smart contract had one public string variable called name and one function called change name. I also created this test script that calls this change name function and changes the string that is stored within this public string variable. I have executed this test script a couple of times just to make sure that this change name function behaves as expected. Now, the first thing that we want to do is to make it so that the function change name can only be called by the owner of the demo smart contract. I will start by defining a new variable in my smart contract, address public owner, and I will set this variable to be the message sender. That means that whoever deploys this smart contract will be its owner. Now, I will add a modifier to my code. This is the only owner modifier. It will require that the message sender will be equal to the owner of the smart contract. Pay attention though, the owner variable is only set once, when the smart contract is first deployed. But the message sender represents the address of the one who sends the message. And of course, in Ethereum, everyone is free to send as many messages as they want. The modifier, whenever called, will compare the message sender to the owner address and will allow only the rightful owner to proceed. Once my modifier is defined, I will apply it to the change name function. So now only the owner can call this function. Anyone else who tries to call it will be rejected. Now let's have a look at our test file. If we run this script test on our modified smart contract, can we expect a change in the results? Will we be able to change the name to Alice and later to Bob? Well, as long as the one who deploys the smart contract is the one who calls the change name function, the answer is yes. The change name function will be properly executed and the test file will yield a success. This is something we can easily check by launching the test file. First, I will run test RPC, and then from within my demo project, I will run Truffle test. And as you can see over here in the results, the smart contract has been properly executed, even though I have this modifier only owner, and that is because the test script only mimics the behavior of one user. This user is the owner of the smart contract, is the deployer of the smart contract, and is also the one who calls the function change name. So how can we mimic the behavior of two or more users in our system? Well, let's have a look and see what happens whenever we launch test RPC. We can see over here the test RPC generates a list of accounts and private keys. More specifically, it allocates some funds, some mock ethers, to each of the following accounts so that we can use them immediately. Truffle, whenever called upon, will ask test RPC for that list. In our test file, that list will be accessible via the accounts object that we have passed to our contract. But if we send a transaction or execute a function without manually specifying the account from which we want to send that said transaction, Truffle will automatically use account 0. This is the default account. In our case, we haven't manually changed the account from which the transactions are sent, so the deployment process over here as well as the two calls for the change name function that can be found over here, are all sent from account 0, the default account. Now we want to make it slightly more interesting. We will leave the deployment as well as the first function call untouched, so both will be executed by the default 0 account. But the second function call, the one in which we specify the name to be Bob, this call will be made from another account. We will make this call from account number 1. In order to do so, we will add what is known as a transaction object. You can read more about transaction objects in the Web3 API webpage, and I will leave a link to that in the description below. But in this case, my transaction object will contain only one field, which will be the from, and I will set this field to be accounts1. This way, whenever the function is called, it will be called from account 1, which is of course a different account from the owner account, and therefore the transaction should fail. But before we move along, let's state it in the it description by adding should fail here and here. It won't change the code execution, just make it somewhat more readable. So now let's execute this test file by typing Truffle test. Now that the process has been completed, we can see the results, and we can see that the two last calls indeed failed. However, it is considered a bad practice to rely on a failure whenever checking your code. It is messy, hard to follow, and worst of all, you might receive a false negative. That means that your code execution will fail, but not for the reason you want it to fail. If all that you have to look at is this red X over here, how can you tell that your code even was running to begin with? Maybe the X comes from a different type of error. We need to define our test script in a way that will return true whenever the conditions that we care for are met. In our case, we want two things to happen. First, we want to make sure that the second execution over here, the one from account 1, will fail. And the second is that the name stored in the name variable will remain Alice. Checking the second condition is quite simple. We just state that we are now expecting the results as a string to still be equal Alice. Over here it should be Alice, and no more need for a fail. But checking that the function call failed is a slightly more tricky thing to do. In order to properly evaluate a failure of the function itself when dealing with Ethereum, we will need to add another package called try as promised. Let's add it by typing npm install try as promised. This package works just like the original try package, with one exception. It waits for the promised result, and then it evaluates it. Once we have our try package installed, we will import it into our test file, just as we imported our regular try package over here at the top by typing try as promised equal require try as promised. I will also make a slight change to the way I declare my expect object. First, I will just declare a simple try object without the expect, and then I will say that this try object uses try as promised to gain its method. I will do so by typing try use try as promised. And now the only method we care for in this instance is the expect method. Now this expect object will gain all of the method from both try and try as promised. Try will continue to work just as before, only this time it will have a few more methods. It will expect the result to not be an error. It will expect the result as a string to be equal Alice. But this time, it will also contain some other methods. The one that we care for are eventually and rejected. It will wait for the execution of the promised process, and once this promise has been completed, it will eventually make sure that the execution was rejected. So we will change our function code over here in a manner in which we expect this function call to be eventually rejected. So let's see it in action by typing in the terminal the command truffle test. And now we can see that the process was completed and we received only positive results to all of our tests, even to the one that required the function to fail.